if I want to solve this equation right here for x, so I got to get x by itself. So the first step to get x by itself, well, it's connected to this upper piece by division. So the opposite of division is multiply. So if I multiply this side and this side by x, that will cancel, leaving you xy 5 minus x. Okay. Now, how do you get x by itself? Well, it's connected by multiply, so we divide. So divide both sides by y, boom, and there is your answer, x equals. Alrighty, number 2 here is a little bit trickier. In order to solve this, the first step you want to do is get rid of that 2. So it's connected by multiply, so you divide it off. See right there? Divide both sides by 2. That gives you 16, and you have this over here. Now to get rid of this 2/3 power, you have to power each side by the reciprocal of 2/3, which is 3 over 2. Okay, so what do we do then? Well, when we do this one we're going to simplify down. And how did I know to put a 4 squared there? Well, because I am square rooting both sides, that's what the 2 on the bottom means. What I'm going to do is I need to think of that as I need to think of what squared, because the 2 on the bottom gives us 16. I'm thinking what squared gives us 16. So I realize, oh, that's 4 squared. Okay, because my goal is to get those 2's to cancel and give us a simplified kind of a piece, a number. Now, why do I have a plus or minus? Well, because when you square root both sides, it's a plus or minus. Now again, that is a 1/2 power. Our denominator 2 is a square root. All right, it originated with a cube root, that's 3, but when we square rooted, or 3 over 2 powered both sides, we are now left with this right here, plus or minus. Over here we have the x minus 5. Again, how do I know if 4 is squared? Because 16 is 4 squared. Why do I know I look for squared? Because the denominator is squared. How do I get this becoming 64? Well, the 2's cancel, leaving you 4 cubed. 4 cubed is 64. Don't forget the plus or minus. Okay, now that plus or minus is easy to forget because you don't normally see a square root as a fraction very easily. Next, I add the 5 over. When I add the 5 over, I now have 5 plus or minus 64. That's this right here. And now I have 5 plus 64 and 5 minus 64. Those are my two answers. And I always want to check to see if they're extraneous. So if it's put 62 into this original equation right there for x, sorry, 69, I said it wrong, and for x, that's what I did right there. 69 minus 5 is 64. Now, that's a little confusing, but see the cube right here? I'm looking for a cube root, so what I know is 69 minus 5 is 64. The cube root of 64 is 4. 4 squared is 16. 16 times 2 is 32. We're good. Now that was a little tricky. Might have missed you a little bit. This right here, negative 59 minus 5 is negative 64. The cube root of negative 64 is negative 4. Squared is 16. 16 times 2 is 32. So we're good on both sides. Again, you have to be good with knowing what a fractional power is. Sorry I didn't show you how this equals 16, how they both equal 16. I didn't show it in the work, I'm sorry. But hopefully you can follow the idea here. So let's start from the beginning. Divide by 2. 3 over 2 power both sides. Realize this needs to be a 4 squared, so they cancel, leaving you 64. And then making two answers. Checking them. Make sure you check. Both of them worked. A lot of times they don't work for reasons, and you have to look for, they're called extraneous when they don't work, so be very, very careful. Alrighty, now with this one, I am graphing a cube root graph. So a cube root graph has this look. My HK is 3, 2, because it's the opposite of this, negative 3. So it's 3, negative 2, 3, negative 2. So go over 3, down 2. There's my HK right smack in the middle. Okay, now what does the 1/2 mean? The 1/2 is your A value. It's telling you you're going to go over 1 and up a half. And then you make your kind of like a square root graph. And then here you go over 1, down a half, and make your kind of upside down square root graph the other direction. It kind of looks like two square root graphs going in opposite direction. So again, first find HK, then look at your A value to see when you go over 1, how far up or down you go. is your a value. And then you have your cube root graph. Number 4 here, I want to write an equation for this graph. So, first thing I need to do is find hk. hk is over 2 down 4. So my h is over 2 to the right, so the opposite is negative 2. And then down 4 is right here, and down 4. So that is hk right there. What is this 2? How do you get this 2? Well, from hk, when I go over 1, I went up 2. So that's how you find a. You're working backwards. Remember, square roots always have this right here, one-sided. If it was a cube root, it'd go down and across that way. This is a square root. hk, a value tells you over 1, up 2. And we got the equation. Alrighty. In order to solve this equation here, what we're going to do is you're going to square both sides. That's what we did here in the green. By squaring both sides, right here, we lose the square root, so that's x plus 13. Over here, I FOILed x minus 7 times x minus 7. When I FOIL x minus 7 times x minus 7, I get this. Next, I now got a quadratic, so what I need to do is get it equal to 0. So to get equal to 0, I minus these two pieces over, and now I have this quadratic. And I always like to try factoring, and as you can see, it works. If factoring didn't work, you'd have to use quadratic formula. But it does. Nice. So I now get negative 3, negative 12, because 36 on top, negative 15 on bottom. These two multiply to get that and add it at the bottom. So those are my factors, x minus 12, x minus 3. So the solutions to this equaling 0 are the opposites of both, so 12 and 3. Now why did I cross out 3 here? Because it's extraneous. And here's why you have to check your answers. It's very important to check your answers. When I go back to the original function and I put 12 here and here, I get this becomes square root of 25, this becomes 5, and the square root of 25 is 5. Yes, we're good. But when we plug in 3 to both of these, that's right here, this gets 16, but this gets negative 4. The square root of 16 is not negative 4, so this is not possible. This is called an extraneous solution. So my only answer is 12. So be very careful to check your work. Alright, in order to graph a 1/2 power, you first have to realize a 1/2 power is a square root. Oh, so it's a square root graph. So that's why it looks like this. Now, so again, for square root graphs, your hk is 4, 1. Remember the opposite of this. So you see I went over 4, up 1. Alright, so that's my hk. That's where I start. So how to get this dot right here? The negative 3. Tells us to go over 1 and down 3. That's how you always find the next dot using your a value. Okay, that pattern doesn't keep working. It just works for the first dot. Then you just make this swish like this. There are more dots to this graph you could make, but we just need those two to get the basic look of the graph. Whenever there's a negative here, it's an upside down square root graph. And again, hk are these two. And lastly, you have to realize a 1/2 power is a square root. Remember, the denominator of a fractional power is the root. And this is a 2, so a square root. Alright, to solve this one, this is a square root. A 1/2 power is a square root. To get rid of a 1/2 power, you're going to square both sides. First, because you know it's a square root. Second, because when you multiply these powers, you get 1. So this would just become x plus 2. And 10 squared is 100. Then, you minus the 2 over. My answer is 98. But we have to check it. Always check. So my answer is 98. Let's check. When I put 98 in for x, 98 plus 2 is 100. And remember, 1/2 power is a square root. So, is the square root of 110? Yes. So we are looking good. Alrighty, for this one, I want to find the value of this. So what I like to do for finding the value, my favorite way, is to see that denominator, that's a cube root. So I want to find something cube here. And it's kind of hard to notice, but this is 6 cubed. So 216 is 6 cubed. Again, you want to find whatever the denominator is, the root, technically. And then, so, I noticed that's 6 cubed. So then you multiply the powers. When you multiply these two, that becomes 3 over 1 times 2/3, which becomes, when you multiply straight across, 6/3, which is 2. So that becomes 6 squared, which is 36. So that is one way of doing it. There is another way I kind of want to show real quick, and that is to, remember, this means it's a cube root, and then you're going to square it. So what you could do, technically, is you could write, we're doing the cube root of 216. But then we are squaring that. That's another way to think about it. And when you do that, what you notice is this right here, the cube root of 216, is 6. So what you end up with is 6 squared, which is identical to here, 36. So either way works. If you like this better, go for it. If you like this, go for it. In order to find the domain and range of this function, you probably want to graph it. So hopefully you know your hk is negative 3, 0, because there's nothing out here. So negative 3, 0. A value is 1, so you go over 1, up 1, boom, there's my square root graph. Alright, so if that's my square root graph, my domain is my left to right. So what you notice is your graph starts at negative 3, and your x values go to the right of that. So your x values again go to the right of negative 3. Right is greater than. They say y values, your x values go to the right of negative 3. Your y values are how far up or down it is. So your graph starts at 0 and goes up, 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 up forever. So your y values are going to be greater than or equal to 0. Remember, range is y, up and down. Domain is x, left and right. And square roots will always be one-sided. It always starts from your hk this way and goes from your h this way and your k up, if that helps. So, all right, in order to solve this one, to get rid of this 1/2 power, which is a square root, we're going to square both sides. So see, we squared both sides. So this gives us x squared. This right here just leaves us negative 2x plus 15. So since I have an x squared, I know I have to probably do a quadratic. So I move these two pieces over. So added the 2x minus the 15, got this. So now I am factoring this right here, and I get x plus 5x minus 2 equals 0. So my solutions are the opposites, because this makes negative 5 makes this 0, and positive 3 makes this 0. But don't forget to check. As you can see, I cross this out, because 3 is your only answer. 5 is extraneous. Watch how it works. If I put negative 5 in right here, what you notice is, when I put negative 5 in, that becomes 10. 10 plus 15 is 25. The square root of 25 is 5, not negative 5. So, boop, gone. When I plug in 3, right here for x, I get negative 6. Negative 6 plus 5 is 9. The square root of 9 is 3, so we're good. So 3 is your only answer, not negative 5. Please, please, please check for extraneous solutions. For negative 11 here, I am solving for x. So I can get this guy by itself, so let's get rid of this 6 first. So to get rid of 6, it's a positive 6, so I'm going to minus it over. So I get x minus 6. Now I have this negative here. Okay, I get rid of that negative. So to get rid of that, it's like a negative 1 in front. So I have to divide by negative 1. That'll cancel. And I get this. Now be careful here. When I divide by negative 1, I could leave this, but it's easy to divide by negative 1. It means to divide both of these by negative 1. So that becomes a negative a, and that becomes a positive 6. I just flip-flopped it. For some reason, I don't like negative a's plus 6. I wanted 6 minus a. So it's just my preference. But just realize, if that was like a 5, you just leave it in a big kind of ugly fraction. But this one kind of nicely simplified. Okay, so where do these red squareds come from? Well, to get rid of the square root, you have to square both sides. Now don't FOIL this out, just leave it. And you're left with that on the left, and on the right, the inside is what we have now. Okay, now we got to keep solving for x, so let's get set x. So I'm going to minus the 1 off. That leaves us this on top. And then I'm going to divide by negative 4. So divide that negative 4 off, boom, and I get this bad boy. Kind of really ugly, really, really ugly. All right, so this would be the equation of x equals. We're just rewriting the function for another variable. A little complicated one here. Let's solve number 12 for x. It's a little bit easier one. So I first have to get rid of this 3. Before I get rid of that square root, I first have to get rid of the 3. It's multiplied on, so I divided it off. Boom. Then, to get rid of square root, you square, and you get 81. X is 81. Done. Let's check it, though. Plug in 81. The square root of 81 is 9. 3 times 9 is 27. Boom. We're done. That was kind of nice and quick. Alright, we want to find the inverse function of this. To do the inverse, what I like to do is I like to replace f of x with y. It just makes it easier for me. So I'm going to replace it with y. And then what I do, if you look from the red to the blue, do you see how I switched x and y? I switched the variables. That's the first step on inverse. And then after you switch the variables, then you just solve for y again. So let's get y by itself. That's multiplied on, so I divide by 6. Next, I got to get rid of the square root, so I square both sides. Now, where to get the 36 here from? Because this is x over 6 times x over 6. The top becomes x squared, and the bottom becomes 6 times 6, which is 36. Then, I get rid of the 5, so I add 5 over to get rid of a minus 5, and I just add it right behind. So I have x squared over 36 plus 5. And why do I put the f negative 1 here? Because that's the way you write inverse of f. So it's just important to write it that way. I mean, yes, I put a y here, and I converted it back to the notation they started with. Just remember, if you see a negative 1 on like that, it's saying inverse. And to do inverse, you switch x and y, and then you solve for y. Easier to make y's than f of x in my mind. Alrighty, number 14. Let's find the inverse of this. So again, I put y equals, and then I switch x and y. Alright, so let's get y by itself. First, I get rid of that 8, so I minus it over. Then I get rid of that negative there, so I divide by negative 1, which allows me to divide both by negative 1, so that becomes a negative x and a positive 8. Okay, so there's my negative x and my positive 8, so I rewrote it like that. Okay, so next I want to get rid of that cubed. So get rid of a cube, you cube root both sides. And when you cube root both sides, you got y. I replace y with f negative 1. And there's my cube root answer. Now, why don't I put a plus or minus on a cube root? Because cube roots don't need a plus or minus, because they don't have imaginaries. Square roots do. So if I were square rooting both sides, I'd need a plus or minus in front. Just be aware of that. Alright, here's the last problem. I want to solve this. If I squared both sides right now, this would be really, really ugly. So what I'm going to do is, as you can tell, I'm going to add this second piece over. So I have a square root on both sides. Then, if I square it on both sides, I can just square both sides. Boom, I'm good to go. That's nice and quick and easy. And then boom, what happens? Ooh, that's an easy solve. That's one of your basic solves now. So just minus 9 over, boom, cancel. And then this becomes a z. Then I add minus a 5 over, it becomes 1. So z is 1. Awesome. But check. Always check. Please, please, please. So I put 1 into both z's. So 1 there and 1 there. So it becomes 2 plus 5 is 7. 1 plus 6 is 7. And the square root of 7 minus the square root of 7, yes, it is 0. So we are good. Don't forget in this chapter test to check your answers. If you're solving, check. Square roots, cube roots can have issues. Just be careful.